So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering and Institute of Aeronautical Engineering. So today our topic will be for discussion is satellites. So about satellites we have not yet discussed, but we have just studied about remote sensing till now. So remote sensing, as we know, that is the process of obtaining the information without touching the object physically. Now we are going to discuss where these objects are captured, where this information is captured, through what this information is captured, and how does the satellites rotates in the orbit, and what are the types of satellites we have, how do we receive the signals, how do we receive the information. That all we are going to discuss today in this topic. So let us start with this topic today. So this is the topic about satellites. So before we discussed about the satellites, just let us go through the contents what we are going to discuss today. So we have to discuss about satellites, satellite system parameters, SWAT, pixel and digital numbers, recording energy by sensors, types of satellites and types of orbits. So this is all we are going to discuss, and we are going to learn about the types of satellites, what are the different types of orbit, and how does we receive the information when we do work with any kind of information. So first of all, let us discuss about satellites. What are satellites? So satellites is like something that moves around something else. Like it has to follow a path, a fixed path, and it is known as an orbit. So what happens? There is an orbit. So satellite will be fixed to an orbit, and it will be keep on rotating in the orbit, and it will follow its own path without any contact, without any touching of the object. It will be keep on rotating in its path. So that orbit will be there in the space where the satellites will rotate, and it keeps on capturing the information while rotating in the orbit. So scientists have sent many satellites into outer space that revolve around the Earth. So these satellites continuously take pictures of the Earth. We can use these satellites images to study the Earth surface features. Like we have Earth resource satellites, which gives the information about the Earth resources. Earth resources means like about the water bodies, about the vegetation, about the forest, and all the resources which are on the ground. That all informations are captured by the satellite when the satellite rotates in the orbit and it follows its path. So the science of acquiring and studying these images is called as remote sensing, satellite remote sensing process. So these all images are helpful for getting the further information for the further processing. So now satellite system parameters. So we have two different types of parameters of satellite. One is instrumental parameter, one is viewing parameter. So in the instrumental parameter, we'll see that principle of instrumental parameters, namely wavelength or frequency or polarization and sensitivity or radiometric resolution, are determined by the design of the transmitter, receiver, antenna, detectors and data handling system. So this is all related. Instrumental parameters is all related to the hardware systems. Hardware system means like it is related to the transmitter, it is related to the receiver, it is related to the antenna, it is related to the detectors and data handling system. Now we have viewing parameters. What are the viewing parameters? The principal viewing parameters are determined by both instrument design and the orbital parameters of the satellite. So revisit internal resolution, SWAT, width, illumination and the observation angle, mission lifetime are important viewing parameters of any satellite system. So first thing, instrumental we have to understand, it is about the transmitter, receiver, antenna, detectors and data handling system, whereas in viewing parameters we'll consider the revisit, the resolutions, the orbital parameters and the mission and the lifetime of the are the important viewing parameters. So these two parameters is considered while capturing the information. Now, before we discuss entirely about the satellite, let us understand what is SWAT. So, just now we have discussed like satellite rotates on the orbit. So, this is our orbit. The satellite will be rotating in the orbit. So it will be rotating like this or like this. So depends on the type of the orbit, which type of orbit it is. Based on that, the satellite will be rotating. So it has to follow a path. Now swath is like something like, suppose this is the Earth, and here we have a like path where the satellite has to capture. So swath is like this much band area. This much band area is the swath where the satellite is going to capture. So a satellite revolves around the Earth. The same sensor sees a certain portion of the Earth's surface. The area imaged on the surface is referred to as a swath. So the area imaged on the surface is referred to as swath. That means this is the area where the satellite will see. So if satellite is here, it has to see this much area. So this whole area comes under swath. Okay. So imaging swaths for spaceborne sensors generally vary between tens and hundreds of kilometers wide. The satellite's orbit and rotation of Earth works together to allow complete coverage of the Earth's surface after it has completed one complete cycle of the orbit. Now let us understand with this picture what is a swath basically. So here is like area where it has to capture. So this is the swath it is called as. That means this satellite is viewing here, this portion of the Earth's surface. So it will view this portion of the Earth's surface. So this is called as, this entire area is called as swath. So like this, when the satellite rotates in a orbit like this or like this, so it has to go through a swath. Like this is the satellite. What happens while rotation? It will capture this swath area. Again, while rotation, it will capture this swath area. So as many times it rotates in the orbit, it will capture the area called as swath. Okay. Now, what is pixel and digital number? What is pixel and digital number? Pixel and digital number. Pixel means a small portion of a cell, a grid cell. So in an image, when you check an image, a digital image, you will be finding number of pixels in the image. So these are the pixels in the image. So a small grid is called as pixel, one pixel. So as many close pixels we will see, the resolution, the image will be with good resolution, So if you have less number of pixels, the image will be less resolution. Okay. So each pixel has a numerical value called as digital number. So this all pixels are having a number called as DN numbers. We call it as digital numbers. Means by default it will be having, each pixel will be having some number given by the computer system itself. It's called as digital numbers. So has numerical value called as digital number, and that records the intensity of electromagnetic energy measured for the area of ground represented by the pixel. So the DN range from 0 to some higher number on a grayscale. So this is about the digital number. Means each pixel is having some number is called as pixel and digital number. So this will be there in a satellite images, as the satellite image comes in a digital format. So it has each pixel is having digital number. So if the resolution of a satellite image is higher, then the pixel is more. Pixels are more. Okay. Now here we can understand more better that each pixel is also give x and y coordinates to place it. The image can therefore be described in a strictly numeric terms on a 3 coordinate system, with x and y locating the pixel z, giving the DN display as a grayscale intensity value. Now here we have, suppose this is the ground and this is the area captured. So in this area we will be finding this all pixels. These are all pixels here. Okay, these are all pixels here. So each pixel is having some number. Like suppose this pixel number 1 is having 170, pixel number 2 is having 238, pixel number 3 85, 255, 221, 0. So like this we have different. So like 0 0. This is 0, this is 0. That means this is 0. That means this all 3 zeros are same kind of features which are present on the Earth's surface. Same the way if we see 170, 170, 170 here and 170 here. So that means this 170 is having same type of feature on the Earth's surface. Like this we have 238, 238, 238, 238. So again we can say that same type of features is present on the Earth's surface. So this is called as pixel. Each pixel is having an x and y coordinates to place it. So the image can therefore be described strictly in numeric terms. So this is about pixel number, DN numbers and the pixel. Now let us understand about the recording energy by sensors. So in the previous all the lectures we have discussed about photogrammetry, we have discussed about remote sensing. So there we have discussed about the platforms. What are the platforms we use it for the capturing the information. So now in this slide we will see recording of energy by the sensor. So sensor is like fixed in the vehicle which can just capture the information through the energy reflection or energy absorbance or transmittance. So suppose this is a ground level platform. So here we have a vehicle. So this vehicle is having a sensor attached to it or camera attached to it. So it will capture this ground information. So this is a ground sensor we can say. Now aeroplane we have here. So it will be having a camera fixed to it. So it will capture the information. The sensor is a device that measures a physical quantity and converts into a signal which can read the observer or by an instrument. So remote sensor to collect and record energy reflected or emitted from a target or a surface. Now let us see types of satellites. What are the different types of satellites? So as we know, satellites is something like which revolves around something. Like satellite is like it revolves in a path of the Earth's surface. So in the space it revolves around the Earth's surface. So depending on their uses, we have different kinds of satellites. So what are the different kinds of satellites we have here? So day-to-day use, we will be utilizing many electronic things which are working through satellites itself, like television, cell phones. Our cell phones we use it, like Wi-Fi we use it. So that all depends on the types of satellite we use. So what are the types of the satellites? Let us learn here. So we have communication satellites, weather satellites, and navigational satellites, satellites for planetary and astronomical studies, and we have Earth observing satellites. So let us understand about the communication satellites. What does it mean? So communication satellite means how do we communicate? How do we communicate? So communicating through radio, through television, through phone coverages. So these satellites always look at the same point on the Earth as they revolve around the Earth. So communication satellite is like a satellite which is located very far away from the Earth's surface. So we call it as geostationary satellite. So in the coming slide we will know what is geostationary. So this communication satellite will be very much far from the Earth's surface. So if suppose this is the orbit. So here is the Earth's surface. So your orbit will be very much far from the Earth. So this orbit will be around 36,000 kilometers away from the Earth's surface. So when the Earth, it looks like it revolves at the speed of the Earth rotation. So it looks like it is stationary. That's why we call it as geostationary. So all types of communication like radio, Wi-Fi or television, that all comes under communication satellite. Now next we have is weather satellites. What is a weather satellite? So weather satellites are geostationary. These are also geostationary satellites. So as I said, geostationary means it looks like it rotates at the speed of the Earth rotation. So it looks stationary. So that's why we call it as geostationary. And it is located very far away from the Earth's surface. Our weather satellites are also geostationary. So others are in polar orbit. So we have two types of orbit here, polar and geostationary. So we'll discuss after this slide. So polar orbit, they also provide information that is used for the weather forecast. So weather forecast means day to day weather report, or we'll get to know with the help of this weather satellites. Next we have navigational satellites. So navigational satellites nowadays we are using in most of the fields. It is highly applicable in many of the fields, like are special satellites that help us to find our exact location on the earth. So GPS receivers that you can now buy at many stores use these satellites to show us our location. So like a GPS global positioning system, like in our cell phones also we have a GPS system. It will tell us where we are exactly standing and where is the location of the place. While navigation we use it. If we have to go to one place to other place, we will just use this navigational satellites. Due to this navigational satellite, it will tell us exact location of our traveling positions. So this is very much helpful in finding out the exact location, and nowadays it is very much helpful in all the fields, like while navigation we use it. Now next is satellites for planetary, and this is also a geostationary satellite. Next we have satellites for planetary and astronomical studies. So planetary and astronomical studies, like it is about the point away from the earth and are used to study about the outer space. So when we want to know about the outer space information, then only these satellites are used. Like it is basically used for the astronomical studies. So if we don't use for our regular use, this is just used for the astronomical studies only. Now we have next is Earth observing satellites. So what are Earth observing satellites? That means it has a capability of observing the Earth. That means if you want to know about the Earth surface features, then we have to go through this Earth observing satellites. So these satellites are specially designed for the study of the process of Earth, and many of these satellites occupy near polar orbits, and some also operate in the other types. So as we have two types of orbit, I said geostationary. So this is one, this is the Earth surface, and this is our geostationary, which rotates very at the speed of the Earth rotation, and which rotates east to west and west to east. And here we have one more satellite called as polar satellites, polar orbits, which rotates north to south or south to north. Okay, so this navigational satellites and weather satellites and communication satellites are geostationary satellites, whereas the satellites for planetary astronomical is also a geostationary satellite. Whereas when you talk about the Earth observation satellites, so these satellites are useful for the Earth observation, and it is near polar orbits. So a satellite launched from Earth's surface by a rocket, once a satellite reaches to its orbit, it continues in its orbit and does not require the push on the rocket anymore. So satellite orbits can be different distances from the Earth. So satellite is launched or lifted by the help of a rocket. Actually, it is lifted by the help of a rocket, and so once the rocket reaches into the orbit, it continues to move into its orbit and does not require any push from its rocket. And satellite orbits can at different distances from the Earth. So now, what are the types of orbit? Till now we were discussing about the orbits. So what are the types of the orbit? Let's see. So the path followed by a satellite is referred to as its orbit. So the path followed by a satellite, that means, so this is the Earth and we have a path here. So if the path follows this, satellite will follow this path, this is called as orbit. So two important orbits we have here. So one is geostationary orbits and we have polar orbits. So geostationary orbit and polar orbits. So geostationary orbit are in the same plane as the equator and are about 36,000 kilometers away from the Earth. So the distance from the Earth is 36,000 kilometers. Okay. And polar orbits pass very close to the north and south poles and also known as near polar orbits. So they are about 700 to 800 kilometers away from the Earth, and it's very near to the Earth's surface. It rotates north to south, so it's very near to the polar Earth's surface. That's why it is called as polar orbits. So pole to pole it rotates, and here this geostationary satellite is very far away from the Earth's surface. It is about 36,000 kilometers away. So all these navigational satellites, weather satellites, and communication satellites, this all comes under this geostationary orbits. And polar orbits, all the resource satellites are coming under polar orbits, which will give you the Earth's resource information. So here is like how the satellite orbit looks like. So here is our Earth's surface. This is the orbit here, and here is the satellite which keeps on rotating. Okay. So in this orbit, it will keep on rotating and it will be capturing the information based on the swath, followed by the swath. Given the swath is given to the satellite, the path which is given to the satellite, it keeps on rotating. Now, this is about difference between the polar and geostationary orbit, right? So as I said, polar is like rotating north to south like this. So Earth is moving very slowly, it will keep on rotating. So while rotation, it will capture this area. This will capture this area. So again, it will rotate, it will capture this area. So whenever the Earth moves, it keeps on capturing the area of this Earth surface. Now this is geostationary, which is around 36,000 kilometers away, and this is about 700 to 800 kilometers away. Okay, 800 kilometers away. So that's how the orbits are fixed to a path. So in this orbit itself, the satellite will be keep on moving continuously. It will be keep on moving. So why it is called as geostationary? Because the speed of the satellite will be the speed of the satellite will be equal to the rotation of the Earth's surface. Okay. Now types of orbits. We have different types of orbits here. Just now we have discussed. So geostationary, we call it as geosynchronous equatorial orbit, or from geo Earth plus synchronous and moving at the same rate. We call it as moving at the same rate. So satellites at very high altitudes which view the same portion of the Earth's surface and all the times have a geostationary orbit. So these geostationary satellites at altitudes of approximately 36,000 kilometers revolve at the speed which match the rotation of the Earth, so seem stationary related to Earth's surface. So these allow the satellites to observe and collect information continuously over the specific areas. So weather and communication satellites, commonly we have these types of orbit. So what are the types of satellites we have here is INSAT, GEOS, METOSAT. INSAT, GEOS and METOSATs are the weather and communication satellites. Due to their high altitude, same stationary weather satellites can monitor weather and cloud patterns covering an entire hemisphere of the Earth. They will cover the entire hemisphere of the Earth. Now, this is the very clear picture of the rotation of the orbit here. You can see here how it is rotating at the speed of the same speed of the Earth rotation, right? So this is like rotating at the same speed of the Earth rotation. Here Earth is also rotating and this is also rotating. That's why it looks like geostationary. Okay, geostationary. Now here what you can observe here is, so this is the satellite. This is the satellite. Okay, this is the satellite. So it is receiving the signals to this antenna. This is the antenna. And from the antenna, it is going to the television. Okay, television. So we are able to see the channels, or we are able to see the television. We are able to communicate through this satellite system. So now here you see the rotation at the speed of Earth only. It is showing looking like that. So that's why we call it as geostationary. With the help of this, we are able to see this television information. Okay, television information. So television information means, So this is about we can say communication satellite. Okay, communication satellite. It's a communication satellite which will receive the signals from this geostationary, and from geostationary it goes to the receiver station. From receiver station it goes to the television, and we are able to see the channels or any kind of information in the television. Okay. Now, near polar orbits, sun synchronous. So before one, what we have seen here is this is called as geosynchronous, geostationary. Now near polar we call it as sun synchronous. Okay, so these are near polar orbits, so named for the inclination of the orbit related to a line running between the north and the south poles, running between north and south pole. So it runs from north pole to south pole. Okay, south pole. So here like this, it will run like this. So many of these satellites orbits are also sun synchronous, such that they cover each area of the world at a constant local time of the day and local center. Okay. So at any given latitude, the position of the sun in the sky as the satellite passes overhead will be the same within the same season. So this ensures the consistent illumination conditions when acquiring images in a specific season over a successive years or over a particular area over a series of days. So this is an important factor for monitoring changes between images or for mosaicing adjacent images together, and as they do not have to be corrected different illumination conditions. Example, Landsat, IRS and SPOT. So these are the three types of satellites which are useful for this polar orbit satellites. So polar orbit satellites are useful for land information. Okay, it gives the land information. So like it gives the information about the successive years, and what are the, it will help us to monitor the changes. It will help us to tell the changes between images for mosaicing adjacent images together. So what is mosaicing? Mosaicing is like joining the two images. Suppose this is image number 1 and we have an image number 2 here. So we have an image number 3. So these three images we will get in different single formats. So later what we can do is we can just stitch these three images by assigning the coordinates. If we assign the coordinates in all the four corners of image 1 and image 2, image 3. So while assigning the coordinates, what will happen? This image will just fix to its position, and we can just join these three images to know the continuity of the terrain. So it will tell us the continuity of the terrain, and they do not have to be corrected for the different illumination conditions. So examples of these types of polar orbit satellites we have is Landsat and IRS. IRS is our Indian remote sensing satellite, and SPOT is our France or Paris satellite. So Landsat will give the information about the land information, the resource information. Even IRS will give the information about the land of the Indian remote sensing satellite it is. So it will give the land information with different resolutions, with different sensors like LIS 1, LIS 2, LIS 3, LIS 4, LIS 5. So these are different sensors it will use to get the information about the Earth surface features. So these are all polar orbits. Now see here, polar orbits. Now in this image number 3, we can see how the polar orbit rotates from north to south or south to north. Okay, so it is rotating like this, and it is very near to the Earth surface, like as we have discussed before, 700 to 800 kilometers away from the Earth surface. So it is having a very clear picture of the Earth resources. Okay, so it will rotate like this. Near polar orbit it will rotate, and these orbits have an inclination near 90 degrees, and this allows the satellite to see virtually every part of the Earth as the Earth rotates underneath it. It takes approximately 90 minutes for the satellite to complete one orbit. Okay, so in 90 minutes it completes the one orbit and it captures the Earth information. So all the information, all the changes, the monitoring, the change detection of the land and the changes, the water body information, that all information is given by this near polar orbits satellites, or we call it as sun synchronous satellites. Okay, this we call it as sun synchronous, this we call it as geosynchronous equatorial orbits. Right? So these are the two different types of orbits and the satellite rotates. So this is in the third picture, we can see this is the swath, how it is capturing the information. So it has captured this all information. Now later as the earth will rotate, it will keep on capturing this whole information like this. Okay. Now ascending and descending passes. So most of the remote sensing satellite platforms today are in near polar orbits, which means the satellite travel northwards on one side of the earth and then towards the south pole and on the second half of its orbit, and these are called the ascending and descending passes respectively, like earth and then towards the south pole to second half of its orbit. So ascending and descending passes it shows respectively, and if the orbit is also sun synchronous, the ascending pass is most likely on the shadowed side, and if the earth, while the descending pass is on the sunlight side. Okay, sensors recording reflected solar energy only image the surface on a descending pass. So when a solar illumination is available, then only this sensor will record the reflected solar energy. So active sensors which provide their own illumination, or passive sensor that record emitted or thermal radiation, can also image the surface in the ascending passes. So I hope you remember about the active and the passive remote sensing. So active remote sensing will never use the sunlight. So here active sensors which provide their own illumination, or passive sensors that record emitted radiation, can also image the surface on the ascending passes. So I think I'm clear about this lecture about the satellites. What are the different types of orbit, different types of the satellites we will use for our regular general works, right? So these all types of satellites are very much helpful to get the information about our Earth surface features, and land satellites like polar orbit satellites are helpful to get the land information, and later we can just process with all types of data. And now geostationary satellites are very much helpful in our navigation purposes and our communication purpose. Daily we use this all types of satellites for our regular process. So these are all about the satellites. In the coming lecture we'll discuss about what are the types of the satellites, what are the sensors they have, what are the resolutions they have. So all details we'll discuss in the next coming lecture. So in the references, like you can just refer this MNG Reddy remote sensing and GIS book for the this all contents. You can just refer to that book and just get to know about more information about the satellites. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.